Hello, today we are looking at section T5 in calculus. This is over using the calculator and identities. So our learning goal today is to be able to solve trig equations. We also want to be able to use Pythagorean identities and the double angle formulas. We're starting here with the trig equations. Use a calculator to find theta to the nearest minute over the interval from 0 to 360. The way this is written, 0 is included, 360 is not. So we can use 0 as an answer, we cannot use 360. We could use 259.9999, but not 360. All right, so on this problem, we're starting with a cotangent problem. This is a reciprocal function. Before I can do this problem, I must change this into its reciprocal function of tangent. If I'm going to change this into tangent, I have to use the reciprocal of this, which would be 1 divided by negative 1.192. Now I have it written as a tangent function. So to figure out the answer, I can come to my calculator. I want to make sure that my mode is in degrees, which it was not. And if I'm trying to find an angle, I always am going to have to do secant tan. So I'm going to do secant tan of 1 divided by negative 1.192, and I get this answer. I'm supposed to find the answer to the nearest minute, so now I have to go to angle on the calculator. Angle is going to be located above the apps button. So here's the angle. I'm going to go second angle, and I'm going to switch this into degrees and minutes to the nearest minute. So my answer then is negative 39 degrees and 59 degrees and 39 seconds. Well, there are 60 seconds in a minute, and this is over half of a minute. So I'm going to just round this up. Well, if this rounds up to 60, then this is going to round to negative 40 degrees. So therefore, my answer would be negative 40 degrees. But that's not going to be the answer because I'm supposed to be between 0 and 360. So I have to think about only the angles that go in this positive direction. I can use 0, I can use 90, I can use 180, I can use 270, and I can use 259.9. I can't use 360. Well, negative 40 just means my angle's going this way. Okay, it's just telling me the direction. So if I want to find the angle that goes this way, I would have to do 360 minus 40. And that's going to give me 320 degrees. That's one of my angles. Now, based on trig, there's always going to be two quadrants, though, where this is going to work. So I think about the fact that I'm doing cotangent. Cotangent is x over y. In order for x over y to end up being a negative, either x has to be negative or y has to be negative. So in this quadrant, an x value would be positive and a y value would be negative. In this quadrant, an x value would be negative and a y value would be positive. So if I had a negative divided by a positive, that would give me that negative ratio. So I also need to be in this quadrant. I use that same reference angle. It's 40 degrees. 40 degrees is a reference angle. So to find the angle that starts here and ends here, I would have to do 180 minus 40. And that's going to give me 140 degrees. And so those are going to be the two answers for theta. Now, if I want to check it, I can. I'm going to check and see if the cotangent of this angle gives me that. To do cotangent, to check it, I have to do 1 divided by the tangent of this angle. And if we did it right, we should get negative 1.192. Great. I'll go ahead and check this one. To plug it in, to do cotangent on the calculator, I do 1 divided by the tangent of 140, and I get negative 1.192 for my ratio, so we are good. All right. Use the calculator to find theta now to the nearest hundredth over the interval from 0 to 2 pi. Well, this is saying I can use 0. I can use pi, which is 3.14 to the nearest hundredth. Pi over 2. Well, if you don't know pi over 2, just get your calculator. What's pi over 2 as a decimal? 1.57. So this is 1.57. This is 3 pi over 2, but what's that? that is 3 pi over 2. So as a decimal, this is 4.71 radians. See, now we're using radians. Instead of calling this 90 degrees, I'm calling it 1.57 radians. Instead of calling this 180 degrees, it's pi radians. What about at 2 pi? Well, that's 360 degrees, but 2 pi would be 6.28. So any answers I come up with actually have to be angle measures between 0 and 6.28. All right, I'm doing a cosine problem. So I'm trying to find an angle. I want to check my mode. I want my answer in radians now, so I got to switch over here to radians. And I'm going to have to do second cosine. I'm looking for an angle of 0.3624, 1.19, or we can round that to 1.20. So one of my answers for theta is going to be 1.20. These are also approximate back up there. 1.20 is in the first quadrant. Is it true that cosine would be positive in that first quadrant? Remember, cosine is x over r. In the unit circle, r is always 1. So we just are looking for where is it that x is positive. Is x positive in the first quadrant? Think of a point in the first quadrant, like a point right here. This might be like 2, 1. So yeah, x and y both would be positive. I need the other quadrant where x's are positive. What about over here? Nope, x's are negative. It has to be in this quadrant. So now I'm looking for this angle that goes to 2 pi, but I have this reference angle of 1.2. Remember, 1.2 is less than 90 degrees, or sorry, I should say 1.57 radians. So to find that angle, I'm going to have to do 2 pi minus 1.2, and that gives me 5.08. So those are going to be my two answers to the nearest hundredth for the angles that give me this answer. Let me check by plugging in. What's the cosine of 1.20? It should be this. Yep. What's the cosine of 5.08? It should be the same thing. Ooh, that's a little bit off. Did I round too much? Let's see, what is that reference angle? I'm going to use the exact value here. 2 pi minus, I'm going to use this more exact, 5.08. Okay, it's just because we rounded so much. If I actually were to plug in the cosine of this exactly, of that angle, I bet we're going to get a really nice answer there. Yep, 0.3624. So that rounding, it does make it a little bit off, but it still is the correct answer for rounding to the nearest hundredth. All right, use a calculator to find theta to the nearest hundredth from 0 to 2 pi, so same thing, but we have cosecant. Cosecant, that's going to be a reciprocal function. I have to write it as sine. So if I'm going to do that, I'm going to have to do 1 divided by this in order to change it into a sine. Whenever I want to, like if I ask you to find the cosecant of 30 degrees, I would have to do the sine of 30 degrees, and I know that's going to be 1/2, and so then the cosecant is going to be the reciprocal of this ratio, 2. Same thing here. If I want to be using sine, which I have to do the reciprocal of the ratio. All right, so I'm going to have to do second sine of 1 divided by negative 1.4540. And I get this answer. Is that answer in between 0 and 6.28? No, it is not. At this time, you might want to pause the video and see if you can think this through on your own. I'm going to go through it with you. So the answer that it gave me is a negative angle. So it's going to be going in this direction. But I still have that reference angle. It's going to be 0.76 rounded to the nearest hundredth. But I don't want to go this way. I don't want to call my answer negative 0.76. That's not in between 0 and 2 pi. I want the angle that goes this way. So that means I'm going to have to do If I were in degrees, I'd do 360 minus the angle, but now I'm going to have to do 2 pi minus that angle. And I'm just going to type it in because I already did minus. I'm going to be a little more exact this time. And I get 5.52. So I check, is that in between 0 and 6.28? Yep. So 5.52 should be one of my answers. But I've got to think of another quadrant. Sine and cosecant both have to do with y. Cosecant's r over y, which means 1 over y, because r is 1 in our unit circle. And sine is going to just be y over r, or just y. So I'm looking, this is my y value. Where are y's negative? Y's are negative here, y's are negative here. So I'm going to have to go to the third quadrant and use that same reference angle. I'm going this way, so if I were in degrees, I'd do 180 plus the angle, but in radians, I'm going to have to do pi plus that angle. I'm going to try to be a little more exact here. I'm actually going to come up here and I'm going to multiply this by -1. I want to make it a positive 1. You'll see why. Because I want to do pi plus that angle, that reference angle. So I'm going to do, where's my pi? Pi plus this angle. And I get 3.90 to the nearest hundredth. Okay? If I want to check it out, I'm plugging into cosecant. That's going to be 1 divided by the sine of, let's just check this one. -1.45. Yep, we're good. I'll go ahead and check this one. Watch what I'm going to do. I'm going to just go like, whoops, no, I don't want to do that. Clear. I'm going to go up and get this problem again, and I'm just going to change this. Well, it'd be easier just to type it in this case. Now again, this is a rounded one, so it might be a little bit off. -1.4, see how it's off? If I had used the exact one, -1 divided by sine, go back up here and get this exact one, now it's going to be better, -1.4540. Okay, but because we're rounding to the nearest hundredth, these are the correct answers. All right, unit circle. Unit circle goes like this. Since we're talking about the unit circle, this is 1, the radius is 1. This is an x value, this is a y value. We know by the Pythagorean theorem that a squared plus b squared has to equal c squared. You got to think back, what is x when we're talking about the unit circle? Yeah, x is going to be cosine. So we're going to have cosine squared theta, because x is getting squared, that's cosine. Y is sine. So that's sine squared theta has to equal 1. This is the most basic Pythagorean identity. We usually say sine squared plus cosine squared equals 1. I don't know, it just flows a little easier when you say it. It doesn't matter though. Now I'm going to take this and I'm going to divide it by x squared everywhere. X squared over x squared is 1. Y over x, that's tangent. And 1 over x, that's going to be secant. So now we've got our next identity. Now I'm going to take this and divide by y squared. X over y is going to be cotangent. Y over y, that's 1. 1 over y is cosecant, but then it's getting squared. So these are our 3 Pythagorean identities. You know, as long as I've been teaching pre-calc and calc, I have these memorized now. I shouldn't say that, but like a lot of times I'll just go through and do that little process to figure them out if I ever forget what they are. All right, so we're going to now look at factoring expressions. When you're taking calculus, a lot of times you check the answers and you've got something a little bit different. And that's because of the factoring. So let's look at this first problem. If we were doing some calculus, we wouldn't see this answer in the back. We would factor out a sine x. If I take this and divide by sine x, I'm left with cosine squared x. If I take sine x divided by sine x, I get 1. Now, this looks close to my Pythagorean identities, but remembering that from the other side, it was this. So I want to know, what would cosine squared minus 1 be? Well, I would have to subtract 1 from both sides, and I'd have sine squared plus cosine squared minus 1 equals 0. So if I want to know what cosine squared theta minus 1 is, I'd have to take this over. So therefore, another name for this would actually be negative sine squared. And then I think, what's a positive times a negative? A negative. What is sine x times sine squared x? And that's sine cubed x. That would be our answer. Okay, on this one, when I have a trinomial, I'm always going to try setting up double parentheses. I think, what times what is 1? 1 times 1. What times what is cotangent to the fourth? Cotangent squared times cotangent squared. And then when I check my outers, I get cotangent squared. This is another cotangent squared, and I want to get 2 of them. So if I make both of these pluses, when I multiply it out, I can see that works, right? Well, now I want another name for 1 plus cotangent squared. Looking at the other side, 1 plus cotangent squared is cosecant squared. So this is going to be cosecant squared times cosecant squared. Something squared times something squared is that same something to the fourth. All right, we have 4 terms on the next one. We have sine cubed minus sine squared. This we want to use grouping. When we have 4 terms, we're going to try grouping with 2 and 2. What's the GCF out of these 2? Sine squared, right? So sine cubed divided by sine squared is sine. Sine squared divided by sine squared is 1. If I have subtraction here, I have to factor out a negative 1. Negative sine x divided by negative 1 is positive sine x. Positive 1 divided by negative 1 is negative 1. So now I have 2 terms. I've got this term and this term. Can you see how both of these have a factor of sine x minus 1? So I'm going to factor that out of here. So if I have this whole thing divided by sine x minus 1, I'm just left with sine squared x. Then I have subtraction. If I take this whole thing and I divide out or factor out as sine x minus 1, then I'm left with just 1. And so my answer then, I've got the sine x minus 1. There's nothing else I can do with that. But when I see this sine squared x minus 1, I can come back to this again. Remember how sine squared x plus cosine squared x equaled 1? Well, if I bring the 1 over here and bring the cosine squared over here, what would we get? Right, negative cosine squared. And so probably the best way to write this would be to put this in front so we don't think it's subtraction. And there we go. All right, let's look at this one. Looking at our 2 terms, I can take out a 2. I'm left with 1 minus 2 sine squared x. Excuse me. I'm going to think of another name for 1 that uses sine squared in it. Well, 1 is going to be sine squared x plus cosine squared x. And then that's another name for 1, so I replace that. And now I have minus 2 sine squared x. So now simplifying, the 2 stays the same. I've got the cosine squared, and then I've got 1 sine squared minus 2 sine squared. So that's going to be minus sine squared. I don't think there's anything we can do with that. Because cosine squared minus sine squared, we can't get that anywhere. So we'll just have to stick with that. And you could say, well, is that really any easier? Maybe not. Maybe it's not more simplified. But just recognizing that this is equivalent to this is a really important thing to understand. All right, on these 2, I can factor out a 3, and I'm left with 2 cosine squared of 2x minus 1. And so when I look at this, I'm thinking of another name for 1 that uses cosine squared. So I'm going to keep the 2 cosine squared of 2x minus, the other name for 1 is sine squared plus cosine squared is 1. So I have to replace this 1 with sine squared, and I have to use the same angle, so 2x, plus cosine squared of 2x. See, the angle has to be the same for these identities to work. So now I'm going to have to simplify this. I've got 2 cosine squared 2x minus 1 sine squared of 2x. And then I have to distribute the negative through that, so minus another 1 cosine squared of 2x. And you can put these parentheses in if you want. So simplifying this, I've got a 3. I've got 2 cosine squareds minus 1. That's going to give me 1 cosine squared. And then minus sine squared of 2x. Okay, makes sense? All right, double angle formulas. So double angle formulas work like this. If I've got some coefficient times sine u cosine u, that's going to be equivalent to that coefficient divided by 2 times the sine of twice the angle. The other formula we have is cosine squared u minus sine squared u equals cosine of double the angle. I'm going to come back up here in a minute and show you how we could have made these better. All right. Let me show you why this works, though. Let's say I'm trying to compute 5 times the sine, let's choose an angle, how about 30 degrees, times the cosine of 30 degrees. So I'm trying to evaluate that. A sine u cosine u. So let's see here. The sine of 30 degrees is 1/2. The cosine of 30 degrees is radical 3 over 2 times 5. That gives me 5 radical 3 over 4. That's the answer to that. But what if I had just done this? I can say that I'm going to take the 5, I'm going to divide it by 2, and then I'm just going to do the sine of twice the angle. My angle is 30, I'm going to double it, 60. Well, now I've got 5 halves. The sine of 60 is radical 3 over 2. 5 times radical 3 is 5 radical 3 over 4. See how I get the same answer? Okay, that's just showing you, demonstrating that this does work. So based on that, this is going to become, take the coefficient, divide it by 2, it changes into the sine, double the angle. So these are going to be equivalent. I just did something very similar. On the next one, it says if I have cosine squared u minus sine squared u, that's the same as the cosine of double the angle. So look at the pattern here, cosine squared u minus sine squared u. I don't change the coefficient on this one, it stays 1, but all of this is the same as just cosine of double the angle, 80 degrees. Let me show you that this really does work. It's pretty neat. So I'm going to do the oops, I got to change my mode to degrees. So I'm going to put in the cosine of 40, get that answer, square it, and then I'm going to do minus, use parentheses this time, the sine of 40, get that answer, and I'm going to square it. And that's what I get. That was pretty complicated to type in. This formula says if I just had put in the cosine of 80, I could have gotten the same answer, and it would have been a lot easier to type in. Okay? Now, that leads me back to this. Well, going back to this, I could have made this answer even better. Okay, so for number 4, I'm going to put a little star, and I'm going to say I could have kept the coefficient the same, and I could have just done the cosine of double the angle, and the angle was x, so just 2x. So that's a better answer. Isn't that a lot more simplified? So that's a much better answer than this, than this, than this, than this. So that's the best way to write number 4, and that's what you would see when we get into calculus. On number 5, look at the pattern. Cosine squared u minus sine squared u. We do have a 3 out in front, it just stays. But this says that I can just do the cosine of double the angle, and that's equivalent. Isn't that a lot nicer? Wouldn't you rather put this into the calculator than that? I think so. All right. Down here, I'd like you to try these on your own. Pause the video, and then I'm going to put the answers on here, and you can see if you got them right. Okay, so this is going to be our double angle formula for sine, so I have to take my coefficient, divide it by 2, make it just the sine, double the angle. This one is also that formula for the double angle for sine, so I'm going to take this coefficient, divide it by 2, and I'm going to double the angle. This one I'm going to have to factor out a 2 first. So the 2 stays the same, but when I have this pattern, it just goes down to the cosine of double the angle. For this one, it's this pattern again, so I'm just going to keep it cosine, and I have to double the angle. And these are all equivalent. Okay, so make sure you do the worksheet.